Welcome viewers, in this video we will see the binary to hexadecimal number base conversion from binary number to hexadecimal number. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Now we will go to the topic binary to hexadecimal. Binary means base 2, hexadecimal base 16. So base 2 to base 16 we need to convert. So this is coming under grouping techniques. We need to group the numbers. For example, octal mean we need to group into 3 digits. The given binary number should be grouped into 3 digits. In case of hexadecimal, it should be grouped into 4 digits. Right? So that it is coming under the grouping techniques. Right? So first we will consider this binary number. In order to convert into hexadecimal, we need to group into 4 digits starting from LSB. Starting from LSB, the given binary number should be grouped into 4 digits. So here what is available? 0 1 1 0. Starting from LSB it is 0 1 1 0. Another 1 1 1 1. All ones are available. Another 1 1 0 1. Right? Here totally 12 digits are available. So it is grouped into 3 4 digits. This is one 4 digit, another 4 digit, another 4 digit. Right? So it is written. If any digit is shortage, we need to add 0. But here exactly 12 digits are available. Right? So the first step is given binary number should be grouped into 4 digits separately starting from LSB. Now convert this 4 digit into decimal separately. This 4 digit into decimal separately you have to convert. These 4 digits separately to decimal, these 4 digits separately to decimal, these 4 digits separately to decimal. How to convert this decimal? By using the multiplication, successive multiplication. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. It's go like that. Right? What is 2 to the power 2 means 1. 2 to the power 1 means 2. 2 to the power 2 means 4. 2 to the power 3 means 8. So 8421. The weightage is 8421. That is coming from this 2 to the power 0, 1, 2, 3. So we can multiply with this 8421. Simply we can multiply. Right? This is the normal method. 0 into 2 to the power 0. 1 into 2 to the power 1. But for simplification we can write 8421. So here we need to convert separately. Here we need to convert separately. Here separately. So 8421 is written in each and every 4 digits. Here first digit is 0, only second and third digit is available. So add only these 4 plus 2, 6. This 8 and 1 is 0. 8 into 0, 1 into 0. Only this 1 into 4 plus 1 into 2. So 4 plus 2, 6. Here all ones are available. So 8 plus 4, 12. 12 plus 2, 14. 14 plus 1, 15. Right? All ones are available. Here 1101. First 2 digits available. Third digit is 0. Fourth digit available. So 8 plus 4, 12. This 2 is 0. So 12 plus 1, 13. So 8 plus 4 plus 1, 13. So this 2 is not added. Now got 13, 15, 6. Right? So in this we need to convert into decimal, into hexadecimal. In the hexadecimal, the number 10 is nothing but represented as A, because hexadecimal is a alphanumeric. 0 to 9 as it is the decimal, from 10 onwards it is alphanumeric. 11 means B, 12 means C, 13 means D, 14 means E, 15 means F. Right? So here 15 is available. 15 is nothing but equivalent to decimal hexadecimal is F. Here 13 is available. 13 is hexadecimal equivalent is D. Right? So DF6. Right? So the decimal equivalent, the binary equivalent of this binary number, the equivalent hexadecimal number is DF6. Now we can combine this. DF6 base 16. Right? So in this what we are doing, the given binary number is grouped into 4 digits starting from LSB. If digits are shortage we can write 0, but here exactly 12 digits are available. So grouped into 4. Then write this weightage 8421. According to the digit add this number. Only these 2 are available. So 4 plus 2, 6. Then convert this into equivalent hexadecimal number. If alphanumeric is there, more than 10 is converted into alpha numeric. and combine this value D of 6. So the final value is D of 6. Now we'll go to the second example. 10 111 00101, right? So this is the given binary number. We need to convert into hexadecimal. What we got? 2E5. We got the answer 2E5 base 16. We will see how we got this value, how the answer is we got. So first we need to write this binary number into, group it into 4 digits starting from LSB, 4 digits. So it is what is available, 1010, starting from LSB it is 1010. So 1010. Then 0111, another 4 digits, only 01, but these 2 digits are shorted, I add 00, so it will not affect, the original value will not be affected, 00. So it is, so writing from 1010 is first 4 digit, 0111 second 4 digit, 01 is the third digit, but 2 shortage is there, so written 00. Right? So here only 10 digits are available. First 4 digit, second 4 digit, third 2 digits, another 2's are added. Now we need to convert these 4 digits separately into decimal, separately. So what we do, we can write 8421, the weightage 8421 is written. What is 8421? 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So that only we wrote. For simplification we wrote. Now how to convert this? 0101, second and fourth digits are there. So 8 is 0, equivalent is 0. Only 4 we have 1. So 4. 2 also 0. Only 1 we have. Right? So 4 plus 1, 5. This 1 into 4, 1 into 1. So 4 plus 1, 5. This first and third digit is 0. So we can add, no need to add 8 plus 8 and 2. 8 and 2 become 0. Only 4 plus 1, 5. Then similarly here, first 3 digits available, last one is 0. So this last one becomes 0. Only 8 plus 4, 12, 12 plus 2, 4. 8 plus 4, 12, 12 plus 2, 14. This is not here, this is 14, not 13, is 14. Right? So this last digit is 0, so no need to add this 1, 14. This one is 14. Similarly, yeah, only this 1 is available. The third, starting from LSB, only second digit. So 1 into 2, 2 only. This 8 is 0, 4 is 0, and this 1 also 0. Only 2 is available. Right? Now we got 2, 14, 5. This 5 written as it is. 14, what is the 14 value is available here? 14 is nothing but E. Because in hexadecimal, 0 to 9 as it is decimal, from 10 onward it is alphanumeric. Alphabet, A, B, C, D. The 10 is A, 11 is B, like that. So 14 is nothing but E. These 2 as it is. So 2E5 is the hexadecimal equivalent of this given binary number. Right? So how we are doing? The given binary number is grouped into 4 digits starting from LSB. The digits are sorted, add 0. Then write this weightage 8421. According to the digit, add the corresponding. 1 and 3 available mean 1 plus 4, 5. This second and fourth, 2 and 8 is 0, so it becomes 0. Here first 3 digits available. So 8 plus 4, 12, 12 plus 2, 14. Like that we need. Then we combine this. This is the equivalent hexadecimal number. So in this video we discussed 2 examples to convert binary to hexadecimal by grouping into 4 digits. Other conversion technique also available in separate videos. So subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.